Welcome back. In this graph, you see displacement x versus time t in seconds. We have to understand displacement x is in meters and time t is in seconds. Now, that means a particle's displacement in 10 seconds is from 0 to 5 meters, and then from 10 seconds to 20 seconds the particle did not move because the displacement is constant at 5. And from 20 to 30 there is a displacement again from 5 to 10 meters, and then from 30 it starts coming down, so the displacement becomes 0 again. So where it started it returned back. That's the meaning 0, 0 to 0. Now from this displacement to time graph, what are we expecting to find? In a displacement time graph, we can find the velocity of the particle at some instant of time, average velocity, etc., etc., etc. So let's see how do you find the velocity. So for example, where you want to find the velocity? Let's say that I want to find during this straight line, somewhere during that straight line. So velocity between 0 to 10 seconds is given by the slope. Velocity is equal to slope of displacement time graph. So displacement time graph slope gives you velocity. So if I want to know that this is a straight line, for any straight line the slope is always constant. So the velocity is constant between 0 to 10 seconds. Between 0 and 10 seconds is a straight line, so the velocity is constant. So at 10 seconds, if I want to find the velocity at 10 seconds is equal to slope at that point. That means slope of this straight line. Just instead of 10 we'll put, because at 10 it's changing, so let's put it at some 8 seconds, okay? So at 8 seconds the velocity will be the slope of that line. Slope is nothing but raise over the run. So how much is that? 5 minus 0 over 10 minus 0, which is called 1/2 meters per second. This is the velocity at 8 seconds. That means from 0 to 10 seconds, anywhere the velocity is same. And between 0 and between 10 and 20 seconds, what is the velocity? Velocity at 15 seconds we'll calculate. What is the raise over the run? There's no raise at all. So 5 minus 5, 0. Over the run is some 5. That is because 15 minus 10 will be 5. So it will be 0 meters per second. That means the particle did not move. And again, between 20 to 30 seconds, the particle moved. Similarly, you can find the velocity at any point you want. Now, can we find acceleration from this? That's a very good question. When do you get acceleration? When the velocity changes. The velocity is constant, no acceleration. So from 0 to 10 seconds, the velocity is constant here. Displacement is there, the velocity is constant. We got half meter per second, per second. So therefore, there is no acceleration. But in this case, the velocity is 0. It doesn't change at all. Again, acceleration is 0. Again, from this to this, the velocity is constant. No acceleration. And from here to here, the velocity is again constant. Any straight line in displacement time graph will indicate constant velocity. Constant velocity, 0 acceleration. Okay? But here, it drastically changes from 1/2 meter per second to 0 meters per second. That means there is some change in the velocity, abrupt change. So this abrupt change is not in some certain amount of time, it's occurring in 0 amount of time. So we don't do such problems for calculation purposes for your classes. So what we understand that is this abrupt changes we don't care. We are not bothered now. So but if this is the graph for your displacement time, we can find velocity, we can also find the acceleration. We can see in another problem how to find the acceleration.